Hi and welcome to Calculus 2. We are going to start this segment of calculus by talking about advanced issues in integration. The first topic we are going to take on is called integration by parts. In the lecture today I'll talk about the concept, and in the next lecture we are going to talk about the techniques. Let's go ahead and see what this is about. Okay, so integration by parts. Parts we are going to see later on refers to pieces of an integrand, and we want to use them as clues for how to do the integration. The concept of integration by parts is something that you have seen in Calculus 1. It's a very basic idea of product rule. You remember how to do the derivative of a product. If you have a product, you want to differentiate it. You differentiate the first times the second plus the first times the derivative of the second. That is at the root of what is called integration by parts in Calculus 2. The methods we are going to look at that later on, essentially integration methods that you have already seen in Calculus 1. The formulas that you are going to learn in this lecture are written one of three ways, and this is a very brief version of it. It's u dv integral is equal to u times v minus the integral of v du. Another common form in which this is written and encapsulated is f g prime dt on this side. Here's the product of f and g, and then g f prime on the other side. There is a so-called definite version of this thing where the integral is done between two limits t1 and t2. Okay, we want to go ahead and see what this is. Mathematics is known for having one of the most compact notation in the world, perhaps only second to poetry, or perhaps by now with the texting that the kids do, they probably use as many cryptic combinations as we do in mathematics. So what does this symbol refer to? It's actually a very simple idea, and it's very important to understand what the concept is before we get bogged down with all the tricky integrations and methods and so on. So let's go ahead and review what this thing meant, and in the context of doing that we are going to automatically understand what this one is. They are really the same thing. So our objective now is a review of Calculus 1. So to make this problem understandable, suppose MacDonald has a farm, and his farm happens to be a perfect rectangle. How odd that MacDonald's farm is a perfect rectangle. So, and just to make it look like our problem, let's suppose MacDonald goes and measures his farm, and on this side it measures u, on this side it measures v, and of course we want to know how much land we have, and therefore the area is of course u times v. Now suppose MacDonald has an opportunity to buy a little bit of extra land as time passes by, and he can kind of grow the farm he has. So as time passes by, he attaches a little extra to the land. That little extra, let's call it delta v, and on the other side he buys an extra land, strip of land, delta u. And as years go by, he's going to buy more and more. So this is actually the growth of the size of the land in time delta t. like delta t maybe is 1 year, and then after 1 year he has bought these little pieces. So after he is buying this, his land of course now a bit bigger, so he wants to compare his old area to the new area. So this was the original area, and now we have new area, which is of course a bigger rectangle, which is u plus delta u times v plus delta v. Well, what is that? Let's just multiply it out, you'll see what it is. U times v plus u times delta v plus v times delta, let me write it nicely, v times delta u, and then delta u delta v. This formula might look cryptic to you, but it's actually very obvious what it is. You have additional land here, which is u on this side by delta v. That's what this thing is. And then there is a additional land here, which is v times delta u. That's what this one is. And then you got a tiny piece here, which is delta u times delta v. So if McDonald was interested in knowing how much his land grew, he's gonna just subtract these two. So I'll have new area minus the old area, and of course when you subtract the UVs, this middle portion, this portion is common to both of them. You subtract it, you just have those strips on the sides and that little piece over there. So it's u delta v plus v delta u plus delta u delta v. Well, just to pushing a consistent notation here, this new area minus old area, this is area that's changing, so it's a good idea to call it delta A. And this is, well, all the stuff on the other side. McDonald must be interested in knowing how much his area grew per unit of time. So like this thing, did it happen in 2 years, 3 years or such? So if you divide, well, you know the rate of change of area with respect to time. On the right hand side we divide as well. Delta u divided by delta t plus delta u delta v divided by delta t. Okay, this looks nice. This looks nice. These are reminding us as idea of derivative. This one looks a bit odd. There is 2 deltas up here and only 1 in the denominator. Maybe we can make it look a bit nicer by dividing by delta t and multiplying by delta t. Now everybody has a delta t and everything looks nice and so on. Now we go ahead and take the limit as delta t approaches 0 or just becomes a small quantity. Of course, at the limit in calculus we learned that we call this thing dA dt, the rate of growth of area with respect to time. This is u dV dt. We called it like instantaneous rate or something. This was the average rate of change. This is v du dt. And how about this one? Well, if this is du dt and this is dV dt, these are 2 finite quantities. You multiply them by something that's going to 0, that whole thing is going to go to 0. Okay, because of this extra delta t over here, and these being just some numbers, you multiply it by something that goes to 0, that vanishes. Okay, here's another way of writing in this whole story. Who was A? A was U times V, and you are taking a rate of change of that. This is U V prime, and this is V U prime. So that was the product rule you had in calculus 1. Okay, now what? Now we're just gonna rearrange this thing and get our suppose you want to undo these differentiations. What was the opposite operation? Opposite operation is to integrate everybody. So this is uv prime, say we are integrating with respect to some variable dt, is equal to, this is uv prime dt, and this is vu prime dt. Well, integral of a derivative, by fundamental theorem, the integral of a derivative is just the original function. In v prime du, we write it as dv, differential of v. U prime dt, we write it as du, that's the differential of u. Okay, so therefore this is nothing other than the product rule, which we just integrated back. Now you can take any of these things on the other side and you will have your integration by part formula. It doesn't matter who you leave on one side, who you leave on the other side, just to copy this thing. So I take this one, integral of u dv, and I take this uv and subtract this from that. Well, you might be wondering, why are you rearranging this thing? So what? The idea in practice is that perhaps sometimes you wanted to do an integral that is written in this style, that if you convert it to that, might be easier on you to do than this one was. And that's what we are going to do in the next lecture. We're going to do some trial and error style of approaching this thing. There's some guidelines what to do for your trial and error, not to have too many errors. But essentially it all boils down to trial and error at the end. Now, just as a matter of notation, the various faculty use or various textbooks you use, and there are other styles of writing these things. Sometimes instead of these pairs u and v, we like the u and v a lot. Sometimes they use f and g or whatever else they have. Any pair of consecutive letters maybe is a nice way of liking and making a little formula out of it. So another style of writing this thing is if you have a function, so say f is u and v is called g, and the derivative of g is going to be g prime dt. Now we have f means f of t times g of t minus, now here the roles are reversed, it's going to be g that is not differentiated, and derivative of u is going to be f prime dt. So that's another style of capturing exactly the same fact. Sometimes you apply this thing to a so-called definite integral, meaning this integral is calculated from some number to some other number. So we write it like this: f g prime dt from time t1 to time t2 is equal to f times g, and that is from again t1 to t2, and then the third time g f prime dt That's also calculated from T1 to T2. So these are different forms of writing the same idea. Again, in practice, what this is used for is to make an integral into something a little bit easier, hopefully, that we are going to continue that discussion of how to carry this on in the next lecture. So what we did, integration by parts, we explained what the concept is, how it is written. We are going to practice this thing in the next lecture. Until then, good luck and God bless.